I will tell you. And we are live. Good morning, everyone. Thank you for joining day 2 of Global AI Bootcamp Latin America. Yesterday, we had quite interesting sessions about cognitive services, about bots, about ML.NET. There were sessions in English and in Spanish. And today, we are going to start our sessions with a couple of English sessions. So first, we have Olumide. Good morning.
Hi, good morning. Good morning, everyone.
Where are you joining from?
Yeah, so I'm currently in Lagos, Nigeria. So I'm joining from Nigeria.
Okay, excellent, excellent. So
Yeah.
you are a Microsoft MVP in artificial intelligence for how long?
Yeah, so just a year actually. So I'm a Microsoft MVP for AI, and I cover like Africa regions. So I've just been an MVP for a year.
Okay, perfect, perfect. Congratulations. And
Thank you.
uh, looking forward to meet you. Hopefully, after this situation, after this pandemic, we can meet in the MVP Summit or in any other conference. Yeah.
Yeah, same here.
Thank you for accepting the invitation. And well, I will bring your screen.
Okay.
So to the stream. Yeah, okay. So, well, I will just like to say to the audience, to the attendees, tell us where are you joining from. Tell us your impressions. If there is any question about the presentation, about the topic, feel free to type in the chat. And do you want the questions at the end or through
Yeah,
the
at
presentation?
the
Okay,
end. I will love
perfect,
it at the
excellent.
end of the session.
Okay, perfect, perfect. Okay, so uh, that's it without further ado. So let's get started. Thank you again, Olumide,
Yeah,
and the stage is yours. Good luck.
awesome. Great. Hi everyone. Wherever you are joining from, it's morning here in Nigeria, and I'm really glad to be joining you guys on the Global AI Bootcamp. I'm really excited to be delivering my session today. I'm always really happy anytime I get to talk about bots because it's something personally I enjoy working with and talking about. A little bit of background about me, as you've heard earlier, I'm actually a software engineer and a Microsoft MVP for AI. I'm usually excited to help people integrate AI into their existing software applications just to make them smarter and even like solve really complex problems, right? So that's one thing I really love to do. And today I'll be walking with you how you can get started with Azure Healthbot. But then I'd love to also walk you through what we will be talking about today. So first and foremost, I'll be giving a little introduction to bots. I mean, we can't really get started with Azure Health Bot when we don't know what a bot is. So I'll be doing a bit introduction to bots and its evolution, how it has evolved over the last few years, and why you need to use it. Then I'll move into talking about Microsoft's bot service. Then I'll do a little Azure Healthbot demo, run you through what it's like with Azure Healthbot. Then we'll conclude and I'll provide some resources. Um, so yeah, I think we should just jump straight into it. So what is a bot? I love to see a bot basically as a software application first. I mean, there is the platform part, there is the main action that the bot does. So for you to like interact with a bot, you need a software. So a bot basically is a software application. A lot of times you go on like a website and you see a little bot pop up and say, "How can I help you?" Then start asking you questions. You start asking the bot question and it's answering you. So that's basically the software application. For some bots, it's majorly like chats, maybe on like WhatsApp or like Telegram. or even Microsoft Teams, you see a bot pop up and say, "Hey, how can I help you?" Or, "Hey, do you need to do this?" Or you can even tell the bot, "I kindly add so person to admin." You get so the software application here is the main platform for you to access it. But so that's why I say it's the software application. But then it's way more than just a software application, right? Because there are so many software applications today that we use on various platforms like mobile, web, desktop. But then, like, what is it doing exactly? So a lot of times when you need to perform automated tasks, when you see a task happening almost every time, you are doing same thing almost every time, you can use a bot to perform those tasks. You get so you can use a bot to perform those kind of automated tasks. A bot is also autonomous, meaning it can make decisions on its own, right? So you need to put some logic into the bot to say, okay, you need to, this is how you handle this situation, this is how you handle that situation. Now we'll go into that further into the session. So you need to tell the bot how to handle various situations, and it is autonomous, meaning it doesn't need anybody to like perform its function. So it just like replies based on the logic it has. See it as a computer human that's like has some logic in his head and is replying you or giving some information, right? So yeah, basically that's what a bot is. And over the years, we try to make bots really smart, and I'll talk a lot more about that. So today we try to like learn and use technology, right? Whether you're like a student in school, you want to learn or gain some valuable technology skills. For some people, they want to be software engineers. Probably you want to be learning like algorithms and data structures, learn like front end web development, back end web development, want to learn mobile development. We tend to learn what technology is today, right? But one thing we've not still understood is that we also need technology to learn us, right? And that's the idea of the bot. We need these technologies that exist today. We need those technologies to learn humans and understand how humans behave and operate. We need technology to learn how to answer us, right? We need technology to learn how to coordinate things, how to observe humans, and how to even anticipate various responses and even listen to humans. So unlike like the usual like software engineering, this for this it's more like the AI when you need the model to learn you. You need the model to learn the humans and how they operate, so it will know how best to serve humans. So for chatbots, the technology itself is serving us. So that's why we really need to like use technology to learn us. So you will see a little bit of shift in the past few years, and you will see why chatbots, it's key to learn chatbots in this modern age. Like you would notice in the 1980s, a lot of people used the desktop computers to do their basic operations. And 1990s was when like the internet actually really came up, and we started having like visiting websites, searching for information, and all those stuff. Then in 2000s, we started having like mobile apps, like social media. Um, you see downloads from like App Store. Now you would see a trend in this that gradually we are moving towards having mobile, having something we can use to chat, social media. That's the trend that's been going on and will continue to go on. The future basically is around conversations. Basically, you see people talking to each other in natural language, even with technology. Like the very reason why I can speak to you today from Africa is due to the technology we have in front of us. So you the future basically is around conversations, conversational canvas, even to like bots and agents. Today we now see like a lot of the customer service roles, a lot of them of the repetitive tasks done there are now taken over by bots, and that's really key and important, right? So for you to understand that conversations is the future. So this is one reason why you need to pay attention to bots and why we need to use it. So you see a lot of like the technologies we do, even in the cloud platform where we have like the we have like the platform as a service, software as a service. For chatbots, it's basically a conversation as a platform. You need a platform where people can come and converse and solve problems just through conversations. I can solve people's problems. And that's where you really need to now bring in the developers part of like actually building this bots to like the business part of okay, how do we solve people's problems to like the end user, which are the individuals. How do we even reach out to them? How do we make sure that we are really solving the problems? So yeah, like you see today, like in various chatbots that when you get to a point of chatting with the bot and it tells you I do not understand what you are saying, it will now give you an option to speak to a human agent, right? And that's because bots are not 100% smart yet. That means we are not there yet. There's still a lot of work that needs to be done. And that's why we need people to really like look into chatbots, see how we can like contribute to this area of technology and improve it. So what are the components of a bot? A lot of times you see chatbots and they're like, hey, you're chatting with the bot and it's responding to you. And a lot of even people even think they are like humans that are chatting with you under the hood. But the chatbots are actually not humans, right? They are, and I said earlier, they are autonomous, right? They they've been given the logic to respond to you, right? So now I'm going to walk you through how like they respond to you. What how does it work under the hood? Now the main components of the chatbots are dialogue, intent, and entity. The dialogue is basically what you see. See it as the user interface. So when someone asks you, I would like to book a flight, that particular thing you see as a user is a dialogue, right? The response back, dialogue, everything you see, just as you can see from the screen. But what is the intent? Intent is basically you try to think that how does it work when I ask a chatbot, I would like to book a flight. What is the thinking process for the chatbot to know that okay, this person really wants to book a flight? That is where the intents come in. There is some machine learning model under the hood that works to try to interpret the messages or the information you type to the chatbot, and that's where intent comes in. And today, you don't have to start building all that functionality from scratch. We have services today that are provided for you to actually understand these things because the whole world needs to come together to build something efficient before you can really understand what people are saying. Because your customers are everywhere. Your customers can be from Africa, can be from the Americas region, or even from Europe, right? So when there's a big global community like that, we help the bot to be really smart. We also have the entities. You can see entities as mainly naming words. So, for example, when you say, what's the weather like in France? France is the keyword. Weather is also the keyword. So, there are two things there, weather and France. Meaning, from weather and France, I can tell you what the person is trying to say. The person wants to know what the weather is, in what location, France. So, entities are basically used to pick up keywords. To use entities to pick up the keywords and use it to interpret what the user is saying. So let's take it one by one and really understand what it means. So when we say dialogues, it's way more than just saying it's the user interface. Dialogues are like what you see when you chat with a bot. And I'm going to show you a little bit of demonstration here to really understand like dialogues. So yeah, let's say I'm trying to build a banking application. A member dialog comes in. So you see like your chatbot saying, would you like to make payments or check your balance? This is a programmed bot already asking you this question. So let's say for me, I say I want to make payments. Um, the first thing you see here is the main dialog, meaning like what you see. Once you say make payment, it will try to call another dialog, right? And that's the make payments dialog that you can see. So and that will trigger like a new question to show you, okay, now that you said you want to make payments, who would you like to make payments to? So we need to know the beneficiary of your payments, right? So I can include the account number here, and that will then get the account number for it and say how much do you want to pay. Now this flow here is the make payment dialogue, and that has like processes. So for you to make a payment today, you need to know the account number of the person and the amount you want to pay, and that's what it's trying to get. So this is information gathering. So now that it has gotten the two information, I can now go ahead and process it. And the normal way we process things like calling backend APIs for the banks who will like provide value to like beneficiaries accounts, that is being done. But from the bot side, this is the dialogues that it shows. You can see that. So now what if I say, okay, now I'm done with making payment, I want to check my balance. So the bot will now know that, okay, I am done with the make payment dialogue, I need to spin up a new dialogue, which is the check balance, and that's where you see here that spins up a new check balance dialogue. And that start asking you questions like, which account do you want to check your balance? Is it like your current account or savings account? Then ask any other information you need. So when it does that, then it provides value for you. So yeah, now I have now a new dialogue to check your current account balance, and that is how dialogues work. So you keep spinning up new dialogues one after the other. Then those new dialogues now like provide the information you need. So that's how dialogues generally work. So we really need to build applications that understand people, because we don't want a situation whereby you have a chatbot and I'm asking you questions and almost 5 times you're telling me you do not understand what I'm saying. There is no value in it, right? So that is why we really need to build applications that understand people. And Microsoft today has tons of services that they provide um, for you to actually build smart applications from vision. You can use custom vision, you can use the face API to really to like identify someone's face and even do like face authentication. You can use the emotion API to understand emotions from the face. There's also the video API, the content moderator. You can even like do speech recognition. You can understand a speaker, but that's like after training the model for a while. Understand the speech, translate. We have various translational services provided, even down to the language, knowledge, and the search APIs. These are like tons of services provided by Microsoft today that you can integrate to your bots to make it smarter. So, and that is just little from the various tons of services that we have to do on the cognitive services API that you can actually use, right? So that you can actually use. So we've talked about the dialogues. Now, how does the intent work? Now, for intent, Microsoft has a service today which we call language understanding intelligence service. And what that does is that it helps you to understand from the word language understanding intelligence service, depend irrespective of your language, and it supports. I know it supports the main languages we have today. It helps you understand what the person is trying to say from the language. So let's look at the example here. You say hello, and you're like, "Who? What is Dan Driscoll's title?" From there, like normally, like for us as humans, how we process this is the keywords, the boundary score, and the title. And that is what Louis does for you. It helps you to like get detect the intent of the end user, and also extract the entity. So to tell you Dan Driscoll is the name and title is what he's looking for, right? And the intent is get the title of Dan Driscoll. So from there I can now put this into like an API to say the name is the score and gets the title, then fetch it back and give it to the user. You get so that is basically how the bot works under the hood. You get, but the main intelligence is now how do we understand the language, and that's where Louis comes in, which is the language understanding intelligence service. If you look at the example, when they say who is John, Louis will help you extract the um entity there, which is John, and you can now use that to like fetch John's information and display it to the user. And it's same thing for like different kinds of messages you see. So like there are so many other services today that Microsoft provides with chatbots that you can use. And there's what we call the Q&A maker. So the Q&A maker helps you to like build, train, and publish Q&A bots based on like existing FAQs. So FAQs are frequently asked questions. So a lot of times when you go to like applications, you scroll down to the bottom and see frequently asked questions. So be like, how do I subscribe for the service? Then you see an answer for it. Like that for the various kind of questions they can ask. You can build a chat based on that using Q&A maker, and you don't need to write any code. All you just need to do is to map questions to answers. So anytime you see this question, display this answer. Anytime you see something close to this, display the answer. You can do that with Q&A maker as well. So yeah, I really hope that you've been able to like understand the fundamentals of bots and why you need to use bots and various Microsoft services that are available to you to use those bots. So why do we now need to bring these bots into healthcare? Health is really key for us, and I'm sure one of the things that will be coming to your mind when you say chatbot in healthcare is you don't want to make mistakes in the health sector, because any single mistake can lead to the loss of lives for somebody. So why do we now need to bring in something that is not 100% accurate into healthcare? And I'm going to tell you why. So we need to automate some medical processes, right? There are some processes today in the medical field that um, they are repetitive. Like the nurses keep taking this or keep taking social records every time. You can automate those processes today using the health bot. You can also attend to minor cases in real time. um for example, when the doctor confirms that you, I don't know, have malaria, there are certain drugs already that doctor will prescribe for you. You get that process of prescribing the drug a specified um specified illness for you. That process is repetitive because doctor will always do that every time. You can use a bot to handle that process, and there are so many other processes like that. So for some patients, there are some things that like patients will be going through that they don't have to go through the stress of going to the hospitals. They could do that via a chatbot, right? When like you provide the major basic logics into the bot, and when it becomes serious, you can now connect the patient to um, an actual doctor. So this is why like bots are even really important in the health sector, but you can't use the bot to run the whole process, and that's where like the part of 100% accuracy coming. So you don't need to you today we can't rely on bots to run all the processes in the health sector, but there are some processes that we can rely on bots to do, and I'm going to show you an example for that. That is basically what the demo will be about. So for the demo, I'm going to quickly um so for the demo, I'll quickly switch to a new desktop. Then you need to go to portal.azure.com. Let me just create a new window out of this. That's much better. So let's go to portal.azure.com. For our demo, I'll be creating the Azure health bots using the templates we have on Microsoft Azure. So for us to use Microsoft Azure, you need an Azure subscription, right? There are so many ways you can get Azure subscriptions today. We have the student subscription. Yeah, so we have the student subscription where you get $100 for a year. We also have like a free account for professionals where you can get free $200 when you create a free account. So for me, I have like my MVP subscription, and that's what I'm going to use. So I'll try to log in here and use the authentication. Hopefully, I get this really quick. Um, okay, so I have an authentication code here, which I'll just fill and approve. Yeah. So that will log me straight into Microsoft Azure. So yeah, those are the prerequisites. You need an Azure subscription. I provided like the link to getting an Azure subscription in my slides, so hopefully you can get access to that and go through the links. Okay, so I'm going to place this. So also need an Azure subscription, and I can tell you, I already told you how to get free subscriptions. For me, I just got my like Visual Studio Enterprise subscription reactivated again. That's why I can see my $150 credit still showing. So what you need to do is to search for Azure Healthbot. So today we have like a template sort of that Microsoft already provides for your Healthbot demo. So you can go ahead and create a new Healthbot. So that's what I'm going to do here. What this will do is it's going to create a whole new bot for you with a lot of intelligence already on the fly while creating it. So first thing you need to do is to select your subscription. I have like an existing subscription already, and that's what I'm going to select. You also need a resource group. So see resource groups as a way of grouping various resources together. So if I need to use another resource, Azure Healthbot here is a resource already. If I need to use another resource for the global AI demo, I would put it under like this. I'll put it under the Azure Global AI Resource Group. So for this, I'm going to create a new resource group because I'm using it for the global AI purpose. So I'll just name it global. So I'll just name it global AI, and that should be fine, I guess. Yep. So now I've added that to like the new resource group. Now I need a name for it. So me, I can say global AI health demo. That should work. Yeah. So and this does a check on like uniqueness. If you have like a name already for this, it would not validate that. And yeah, it says it can only contain small letters, so you can't do a camel case here. So I'm going to just change this. Yeah, that will validate. Then for the region, Microsoft has data centers in various regions across the world. I'm in Africa, so I'm going to select a region close to me, right, which is from the information I have here, West Europe. And there are different plans, and the plans are based on how many messages you can send um, per second, right? So for the free plan, you can see you can send up to 10 messages per second, and you have maximum of 3,000 messages you can send. Once you exceed it, you cannot continue using it except you move on to like another plan. You have the standard plan, and the standard plan. So for this demo, I'm going to select the free plan. Then next you do is to I don't need to review it, create it. So I'll go ahead and create this. Um, it does some validations first before allowing you to create it. So creating it, what creation will do is see the creation as you built like a whole machine learning model that you've trained already to like be smart by prescribing drugs to patients, knowing the whole medical processes and all. You built all that model and you want to deploy it. So that's what happens here. Microsoft already has health and world class health partners that they work with to make this model and the bot really accurate. And you are going to see example of how the bot works from the demo. I'm going to speak a little bit about the health bot and how it works while the deployment is going on. So once deployment is done, we will continue. So basically, for the health bot, what happens is Microsoft today um, collaborates with various world-class health companies like Novartis and a few others. So they work with world-class doctors, try to like try to understand what are the repetitive tasks you have around, build a model around it. build a model around it, then try to now get word class descriptions for each of these models. So you can see the bot has already been deployed. I'm going to click on it, and that will take me to the bot itself. Yeah, so if you are familiar with Azure, you'll be familiar with the portal and like ways you can manage your resources here. I would, the difference between these are like various other resources on Azure is for the health bot, it provides you a portal, and from the portal you can go and manage your various activities for the bot. So that's what I'm going to do here. I'll need to sign in here, so I'll just sign in with, okay, yeah. I'll just sign in with my MVP account. Okay. So once you sign in, then it will bring you to the portal, and from the portal you can manage various scenarios of the chatbot, and that might take some time to load depending on your internet. But from here you can like see other information about the bot, like the various activities going on in your bot. And this is the last activity that went on. I deployed the bot. You can also see like access controls. Who can like access your bot? You can grant someone access to like admin access, different kinds of role accesses to your bot. You can also see various properties of the bot here as well. Um, and like the identity, encryption, various pricing tier. You can come here and like upgrade your pricing to let's say another way to the standard one if you want to, and the other information you have here. Yeah, so back to the bot. Now I already have a bot. Interesting part of this bot is you don't need to do anything, you just need this portal. For you to test the bot, you can come here and just type anything for the bot. So yeah, if I come here and say I, you will see some response. By default, the bot is not smart, health smart yet. Because if I say I have, let's say I have malaria, I tell the bot I have malaria, it already has information about basic um it has information about basic health conditions like malaria, like let's say I have fever. It has information about those basic information, right? So what if I ask the bot the question like what is COVID-19? So for you to make the bot even smarter, you need to provide various scenarios for the bot to understand. And that's why this is not providing the main information for COVID-19. And that's because I've not added COVID-19 here. So you can come here and like add a new scenario to your bot, and you can create like your own scenario ID and all, or you can use a template already provided. What the template does is the template is a whole machine learning model already built to like interpret some scenarios. So when you want to your bot to answer questions around COVID-19 or vaccine FAQs or back to work, plasma, you have all that information here. Even booking appointment, if you want your bot to be able to book appointment, you can add that here. Add flu, triage, file a claim, and so many other information. These models that have already been built for you, just use it. So for this, I need to add the COVID-19 triad to my bot, just to help it really understand COVID scenario question. So all you just have to do is to import the template. So once you import the template, your bot becomes smart enough to understand COVID questions and answer those COVID questions. So that's what happens. So I've added that to my bot now. So I can come here and test the bot. So this bot is basically just going to help you answer all COVID-19 related questions. So if I say I, what happens is it's going to spin up the what you call the dialogues. And I talked about dialogues earlier. So it's going to spin up the dialogues and like show and run you through the whole COVID situation. So let's say what Yes. Okay. So let's say let me just say coronavirus. Um, so I'll try to run this first. Yeah, that's why. So you need to first run your health bots. So once you run it through the COVID scenarios and you can start using it. So yeah, the purpose of the you can now see like information about the COVID scenarios and you can always come and update this information. If you want to use this as an hospital, you can update the information. So for me, I want to agree to using my information. And yeah, it tries to ask you a few questions like do you have cough? Do you have this? Do you have that? And it's tell you if the possibility of you having COVID or not. If you need to go to the doctor, it will tell you to go to the doctor. And this has already been built by professionals. All you need to do is integrate this into your I don't know your hospital or healthcare. So yeah, it's asking if you are experiencing life-threatening emergencies, call 911. I'm now asking you if you are in the United States. And I mean, this was built to handle various regions, right? So you can configure it to handle like your region. But by default, it handles the US. So let's say I say I'm not in the US. Then it's asking for answering for someone. I'll just say I'm asking for answering for myself. Um, So it's asking if I'm fully vaccinated. I can yeah, I'm vaccinated, and to ask you a few other questions about COVID, your age. Let's just assume 18 to 29. Then I submit that, ask for sex, ask for basic information that a doctor will actually ask you when wanting to know if you have COVID or not. So how do you describe yourself? I'm male. Look, I'm not. What is your race? For me, I'm black, so I'm going to select that. Then it should now start asking me, do you have any of these life-threatening symptoms? For me, I don't. So I'd say, oh, sure, yes, yes. So based on your symptoms, you may need urgent medical care, and that's because I selected I have trouble breathing, new confusion, inability to do this. So yeah, it's telling me, okay, now you need to see a doctor because you have like you need urgent medical care. And this, I've not really written any code so far at all. All I just needed to do was to use Microsoft's existing Azure bot services. And from here, it's telling me what I need to do, next steps, COVID symptoms, how to protect yourself, and that's all. So is then the bot wants to ask for feedback. For now, I'll just say no thanks. But yeah, with this, you can actually um like you would have a scenario that will cater for COVID situations. And it's not just COVID, there are so many other things you can do here, like booking appointment. You can book appointments with your doctor. So instead of having an actual agent that would start picking up calls and saying when you have to book your appointment, and you would have issues like appointments clashing in an hospital, you can actually use this template to do that. And what that template does is it knows when like a space is filled, so there won't be clashing of appointments. So there won't be that clash of appointments. So yeah, for example, to come here and tell you, do you want to book an appointment? I'll continue, then to ask you to then you can actually always configure this, right? So then you can use this to schedule an appointment. These are repetitive tasks that happen in the hospital where you can actually just use a chatbot to do it. So if you need appointment on any of these, let's say I just want to do an X-ray, um, then it will help you like set it up. So these are selected suggested dates for me to do the appointment. Let's say I don't want Monday, I want a Thursday, and it's just book that for me. So it will now ask for your information and book it for you. And that's straight up. You've already made it smart for booking appointments. So you can use this for other scenarios also in the Azure, but there are so many other scenarios. And it's not just health based, you can actually also build bots outside the health space as well. There's also the bot framework. This is an intro session, so I don't really want to bore you with so much of other information, right? So that's why I'm just using this simple demo to show you. But then like the next question that will be going through your mind is now how do we provide these services to our users, right? So you can you can actually deploy these bots, right? So I'm going to first show you how you can manage it. So you can manage the various scenarios here. You can come and deactivate any of the scenarios. So if you don't want your bot to do appointment again, you can come here and deactivate it, or any of the other things here. Then here you can use this section to check the various models that you have for your bot. And these are the various models that work under the hood. You can also come here and configure like various medicals that provide that service for you. For now, there is the ephemeral and capital. These are the I can switch to capital if I don't want ephemeral. And these are the two major content providers that provide information for your bots. So yeah, you can come here and see integrations, and this is where like I'm going to answer the question of how does your user use your bot. So when you come to channels, you would see the various channels you can actually integrate your bot into. So you can do a web chat, which for now is active, and that's what you are seeing there. Right? You can generate a link and give it to your users to use. You can also use Microsoft Teams, integrate it into an existing Teams, or Trello, or Facebook, or Telegram, Alexa. You can even use WhatsApp. WhatsApp is currently in preview. I'm currently working on something. Hoping I can share it publicly once I'm done with it. But like you can actually create like a number on WhatsApp specifically for this purpose, right? So you can just give your users that number, and once your users chat with the bot, it responds the way it responds as you are seeing it on my screen, right? I think that's like the most effective way to like really connect to your users. So you can use WhatsApp for that as well. You can also give your bots an icon. You can like upload an icon and give your bots the icon. Yeah, and these are various ways you can like connect to your bots. Yeah, and you can manage users too. You can manage users for your bots. So for now, I'm just the main user. You can come and add another user that will be updating your bot. You can add like your hospital people. So yeah, this is basically it on the Azure Health bot demo. I hope you'll be able to see how we can actually use these bots in the health sector. There are so many other sectors we can actually use the bots. Health is just one of those sectors that I'm going to demo to you today. So I'll quickly just go back to the slide. So yeah, the various resources that you can use. Hopefully, I'll share this with the organizer so that you can have access to it. You can read the documentation. There are so many documentations to do on Microsoft Learn. So you can use the documentations to learn about health. There's a C Sharp SDK that you can use to build. If you want to like build your bots from scratch, you can use the C Sharp SDK, Python SDK, or the Node.js, which is JavaScript SDK as well. And we have like samples, like templates for bot builder, which you can use. You can learn more about Luis using these links as well. Q&A maker. You can get information on Azure for students, getting free Azure account and subscription for students. And this is the main bot framework documentation. So yeah, that's basically it for the session. Um, if you have any questions, I think this is the time for us to take those questions as well. But yeah, you can reach me via my email, gmail.com, and that's my LinkedIn as well. You can reach me via it. If there are any exciting projects you're working on with chatbots, kindly hit me up. I would like to like hear about it, and let's see how we can improve the project. Yeah. So thank you very much.
Thank you very much, Olmide. That was an impressive presentation. It was
Thank
really
you.
cool that you could demonstrate it. Okay, so there are some attendees in the chat, so we will wait if to see if there is any question. Well, in the
Okay.
meantime, I can share some messages. For example, Juan is joining from Mexico. Right now in Mexico, it's
Awesome.
3 well, almost 4 a.m., but he is joining. He is actually a student from the same university where I teach. So
Oh,
welcome,
nice.
welcome, Juan. Yes, so really nice. Um,
Awesome.
okay, we will see. Um, Yeah, in this case, what would be the approach, let's say, for the Azure Health Bot if I am, let's say, just a developer? Do I need some background, for example, in some medical terms, or the bot or all the infrastructure, all the technology, let's say, makes it simple for me? Or what would be some recommendations, some approach?
Yeah, that's a really good question.
Mhm.
So when you want to build with an existing template like the
Mhm.
Azure Health Bot, you actually do not need a background in software engineering or coding, because everything you've seen me do in the demo, I did not write any code. All I just
Mhm.
needed to do was to know where to in the portal I need to go to, know how to manage it, and also know I would need to know like what scenarios I need to handle. So you would need a little bit of experience, understanding of how the health sector works as well, because you can't build for a sector that you don't understand how it works, right? So I think the major thing is really understanding how the health sector works. Know what your end users need. Like for example, an hospital will need to handle situations for COVID, handle situations for booking appointment, for
Mhm.
flu. So all those situations, you need to know them, and you need to know how to manage them. So you don't need any coding experience, but you need to understand the health sector so that you can build for it. I think that's really the main idea of actually the
Yes,
health
yes.
bots, so that we don't need to focus on the coding. We want to focus on the problem. What is the real problem? The real problem is health sectors find it really difficult to automate tasks because they have that high level of accuracy that they need. So we can automate the small tasks for them so they can focus on the main tasks that needs high level of accuracy. So this way, the doctor doesn't have to worry about how do I manage booking appointments, or worry about answering questions about COVID. All the doctor needs to worry about is, now that I have a main problem, how do we like treat these patients and solve their problem? So yeah, you don't need a coding background. But if you want to build a bot from scratch using the bot framework SDKs, and that's where you now need a coding background. Let's say you want to use the C Sharp .NET SDK, or the JavaScript SDK using Node.js, or the Python SDK. That's where you need like a coding background.
Perfect, perfect. Okay, yes, it's quite a complete answer. You covered several points, several elements. So, okay, thank you very
Yeah,
much for your recommendation. Also,
thank
Juan
you.
shares his point of view. It was an amazing session.
Awesome. Thanks, man.
Okay, so I think there are no more questions. So
Awesome.
thank you very much again for joining, for reaching, let's say, some audience, let's say, in another continent. So most probably people will watch the recording later,
Yeah,
because as I said, in America right now it's a bit early, but still there are some guys here, or maybe also some people joining from other countries. So it was
yeah,
amazing. So looking forward to meeting you in another conference, and all
yeah.
the best.
Yeah, thank you very much. Thanks for having me, and I hope you all enjoyed the rest of the session. Bye, everyone.
Thank you very much. Okay, so have a great weekend. Bye bye. Okay, so that was a great way to start these sessions. And well, let's continue. We are in really good pace. Uh, Now we have a second presentation from Sebastiano Galazzo. Oh, yeah, he is already here. Oh, so let's add him to the stream. Hello, Sebastiano. How are you doing?
Fine, thanks.
Okay. Where are you joining us from?
From Italy. I'm based in Milan.
Oh, yes. If I checked correctly, yesterday you organized, or you were part of the Global AI Bootcamp in Milan, right?
Yes, I talked about GPT, so NLP, because today we will talk about the avatar, but of course the project is much bigger and is made by several sessions. So the avatar can interact with people using, of course, NLP engine. And so we worked with the GPT, and with that session, I wanted to highlight that maybe that they are not so great as people believes, and I realized that right now, for a lot of tasks, maybe Microsoft Lewis is still a good option. So don't rush to use GPT, because there are several aspects that are still to fix or not suitable for all scenarios. So yesterday I talked about the language, and today we talk about the audio video.
Yes, yes. Let's call it work in progress, because when you try something, you learn something new, and it can be useful maybe for another project. So
Yes,
okay.
because this is the reason why I like to join this kind of conference, because I really spent my last 2 years in research and development, and I did tons of fails. But believe me, tons of fails. Before you arrive to reach a result, you have to fail a lot. And so the goal on my presentations is to highlight failures, because if I tell you where I failed, maybe is much more helpful for you than tell you how I did something. Because, for example, at the end of this presentation, I shortly present my how I organize the Azure for the streaming of the video. But honestly, okay, that's very important, but you can find the documentation on the web. We will talk about that, but the first part, where I will share some tips for you, it means 5 seconds to hear my tip, but to me, it means 2 months of sleepless night and how to fix that bug. Let's say bug, but it's not a bug; it is a problem. So that's
Exactly.
what I wish to do, and I hope the people enjoy this session.
They will definitely enjoy it. So thank you. Yeah, that's very interesting and looks promising. Okay, so if you want, you can start sharing your screen, and we'll bring it to the stream. So I invite the audience. If you have any question, feel free to post them in the chat, and we will add them. Let's say we will ask Sebastiano later about it. So, okay. Yes, I can see your screen. All right. So thank you for your time. Thank you for your collaboration. The stage is yours. Good luck.
Thank you to you for the invitation, of course. I hope that you will be able to listen my audio system, because I will show you a video of the final content, what we are going to create. And before that, I had already my introduction talking with Lewis. But again, what I want to do with this talk is a bit difficult, because it is always difficult to balance the high technical part with the storytelling. And so I tried to do my best. I hope that you will enjoy it. So the first part is focused on deep learning. So how I built my deep learning project, model, sorry. And the second part is related to how to put everything together. Anyway, Why we decided to create everything from scratch when talking about the avatar? Because maybe you know there is already a service that is named Synthesia that does something like that. So first of all, for money, because we want to release a product and we have to create a lot of these videos, and so to have the technology inside is a cost saving compared to buy always a video or a product from a third-party service. Anyway, in this way, we are able to produce our own avatars, so with actors we want. Instead, if you use third-party services, you have to use that faces, and if you want custom avatars, you have to pay a lot. And there is, we don't want to reinvent the wheel, but in this case, there was nothing open sourced from start with. Yes, in GitHub there are few projects, but nothing that arrived to this kind of quality in terms of photorealism. And here, quickly, I will show you a result. And I hope that you will be able to listen to the audio.
Hi everyone, and thanks for attending this session. This is the digital version of a real person, generated from a text by a sophisticated AI, result of an intense year of research, development, and most importantly, great passion. Today we will talk about my creation. Enjoy.
So let's see how I produced all that. But first of all, let's talk about the application fields. So chatbots, of course, is the first option. So in the session before, you were able to see how to create a web chat using bot framework. We do use bot framework, of course, and in this scenario, we put together both the web chat and an avatar in order to make easier for people to interact with your service. And here, in this case, you have to connect the bot framework with this kind of interaction, so you need some modification. And so the web chat that we used from Microsoft has been a little bit customized. And a second option is related, for example, to engage people in a digital campaign, so creating a landing page. And the goal is to have a more engaging web page with your customers. So let you imagine today that you create your own campaign, for example, with Google, and the old way, let's say the old way makes that you have a web page with a banner, maybe a web chat if you are really advanced, but you have to wait that people interact with you. In this case, it's the avatar that engages you, makes the first step. So it should be much more engaging, and is a product that we want to release as soon as possible, but also you can do something like that. Of course, on devices like Alexa or Google Home, we are thinking to include this technology inside home devices. But much more info totem. For info totem, I mean a device in the shopping centers, for example. So when you enter and you need information, you have this big screen in vertical with an avatar to interact with, providing information in natural language. And so I know that already exists stuff like that, but in high high-skilled companies, a tech company, the goal here is to provide this kind of solutions for all companies, and not just for rich people. And finally, really not finally anyway, the automotive. I know that could be strange, but we have been contacted from some car builders building supercars, and this is an ongoing project, of course. And the goal is to include the digital avatar inside the vehicle. So we have to study how to make it safe, because of course they can talk when driving, but looks like that will be the future. And how don't talk about the metaverse, that is a current hype, and avatars and the ability of interact and engage other avatars or other people will be a great challenge in the close future. So this is a technology that has several fields of application. Well, here the workflow that I use to create everything, and start really from the shooting. So we do everything from scratch. And when I say everything, it means everything. So I'm a photographer, so I've had the luck to have good cameras, and I studied also the shooting. The shooting doesn't mean just having a camera or lights or the green screen, but with my team we studied a special text. It is a text that contains all sounds of the language, that is named phoneme. In this way, we don't need to cover 10 hours 20 hours of recording of a single person, but more or less in just 6 minutes of recording, we are able to produce the result that you watched at the beginning. And that's the first key point that I share with you. The text that is used while shooting and then to be used for the training of the deep learning model is really, really vital and very important. Because if it's not well balanced or does not contain all sounds, it means that you will be not able to make it speech very well. And after shooting, of course, we post-produce everything with Adobe Premiere, After Effects for green screen manipulations, and so on. After that, there is one of the most important steps, that is the audio processing, that is not just related to deep learning, but first of all, for example, noise reduction. This step is very, very important because I don't know how much time to realize where the problem could lie, because we will see very, very soon how it works, but when extracting frequencies and analyzing the frequencies of the voice, if there are some noises that produce very bad problems, bad results in the input, and then it means that you will not be able to make your model working. So pay a lot of attention on noises, ambient noises, much more. Then there is, of course, the step of the training. We will see how it will be done. Finally, we have our inference, where starting from our input, we produce the final frame, and then frames, and then we put everything together. So let's see much more in detail how it works, starting with one of the most important steps. So the audio processing. I don't know if all of you are aware of what it is, the Fourier Transform, but it's something that changed the human course since hundreds of years. Anyway, is a math tool that is able to extract the frequencies from the waveform and to convert it into from time domain to frequency domain. This is because the frequency domain are much more suitable to be used as input in a deep learning model. But how it works exactly this step. So we claim to create this video starting from a written text. So what I do right now, because this project changes a lot, but right now I use Microsoft speech-to-text to convert my text into a WAV file. This WAV file is then processed by algorithms that I developed, but we are not talking about rocket science, because I use LibreRosa, that is a famous library that you can find in Python, for example, to manipulate the audio. My research was much more on how to calculate the best parameters. Anyway, how it works. Starting from the waveform, so our U is converted in a file, we apply the short time Fourier transform. It's something different from the Fourier transform, because the Fourier transform gives you the information of all frequencies in your audio. Doesn't matter how large is it, maybe 1 second or 10 minutes. Doesn't provide the position of each chunk of audio. So we use this technique that is named the short time Fourier transform, that exactly how I explained before. The audio is split in very, very small chunks. We will see after how the size of this chunk, that is vital and very important, will be calculated. And for that small chunk, match 1 frame of my shooting. So the model will learn that for that sounds match that shape of mouth. This is more or less the idea behind. So anyway, that's not enough. We cannot use straight the short-term Fourier transform. But why? Because of how the human brain works when talking about sounds. So the humans can detect sounds from 20 Hz to 2000 Hz. But the human voice ranges between 100 Hz and 3000 to 200 Hz. Anyway, said that, like for the music, the human ear is much more sensible in catching differences in sound modifications in low range frequencies, so in low sounds, than in the high sounds. You can do a test and you can realize that you are not able to catch the difference of high sounds compared to low sounds. This is the reason why we apply this transformation that is named MFCC, or Mel Frequency Spectrum. You can find a lot of documentation on the web. But basically, what it does is to compress the representation of each column of the short-time Fourier transform in a way that is much more suitable to be understood for the human brain. So basically, we cut a lot of information that basically is useless, because if a human voice ends after 3000 hertz, and from a math point of view, the Fourier Transform is able to extract frequencies up to 20,000 hertz. All that information, from a numerical point of view, being useless, impact in a bad way in my training, because there is much more than the core that I need. This is the reason why. So when talking about MFCC, one of the most important parameters is how much compression it must process. In a lot of projects that you can find on GitHub, you find that this parameter set to 18, but in this case I use a value that is 128. So I decided for much more information. Anyway, again, another how to extract the column with a technique that is named windowing. So basically, we apply a filter having this shape of a wave for each column. But it is vital to understand that the size of this filter, the length of this window, and the shifting impact a lot on your final result. So I studied a lot on that and to find the best parameters, and it's not easy to do, because in a lot of projects that you can download from GitHub, working with audio, everything is much more compressed, because you have to extract much more details for something else. Here is a completely new task, so I had to search and find new solutions. So the shift is the op length, and it means also how much overlap must be between one column to another. When I say column, it means also frame, because to each column correspond one frame. Well, say that I did a lot of tests, and I was not able to find the best parameter, because if it was too small, highlighted some feature, but has a lot other cons, and so on. So I found this solution that I found after really tons of tests and tons of studies. And what it means? Well, it means that the audio input of my deep learning model is made by two inputs. The first, on the left, is basically made by three values, and is managed by as it was an image, having 8 free and the length the size of the MFCC computed before. So what I realized is that okay, I have to process the frame, the current frame, that here is named center window. So the center window is the current frame, and I thought that would be a good idea to bring information about what was before and what there is after my current frame. That because sometimes at least in Italian, but I guess also in languages like Spanish, all Latin languages, maybe the shape of your current vowel that you have to go into speech changes if you are going to say, for example, the letter P or the letter A again, and then it's important to understand what there is all around you with a smaller window length. Or in this case, I use the same length for each frame. Then we will see how it's been calculated. The second input is always centered in the current frame, but with a wider window. As you see before, the window is has a shape that is fade on the sides. So having this shape, I put much more importance to the center and much less in the corners. But it's important how wide is it. Well, so I use this kind of structure. And finally, of course, I need my reference frame in order to reproduce my final my final frame, but with this area modified and modified accordingly with the new input. We will see how that will be made. But let's talk now for a while about the overall architecture for people that maybe know something about machine learning. Is not something new, but it's important to introduce autoencoders because everything has been developed with this architecture. So for people who don't know what they are, an autoencoder is a structure made by two neural networks. The first part on the left is named the encoder that takes an input and with several convolutions and the steps goes to what is called the latent code. That is a representation of the input. Basically, what it does is not just a compression, but with this process we extract all the feature of my input, that it could be an image or audio. And on the other side, of course, we have the decoder that, as the name suggests, takes in input the latent code and try to reconstruct my original input. Keep in mind this structure, because at the end I will show you a technique that improved a lot the final quality. So again, quickly, we have an encoder. The encoder compress and extract feature in a very small array that is named the latent code. That latent code is used by the decoder to reconstruct the original input. Well, this is the architecture of my deep learning model, and in my knowledge is something new. Why? Because here what I did in the upper part we have the encoder, and here the encoder is made by two encoders inside. In the all projects that you can find, of course you have just one encoder and one decoder. You can see that there are several techniques but are related to the decoder. Nothing about having this kind of architecture with the encoder. Anyway, I don't believe that I discovered so what. How it works. Here we have the encoder audio that is completely standalone, and there's a reason why at the end I decided to split that information. I will talk you soon why. And on the other part, we have just the encoder that is able to compress and reduce the reference image. One key point is that the video encoder, the encoder in red, is not connected to the Latin code, but I skip this part and I use an architecture that is like the UNet. You can find the documentation on the web using skip connection in order to help the layers in the decoder to reconstruct with a high quality the final frame. Why I don't connect this encoder video to the Latin code? That's another very important tip that I want to share with you. Is something that I discovered, let's say. That's because the image brings a much bigger amount of information compared to the audio. And then what happened was that basically the model learned much more from the image and was not audio driven. And that's very important. So this is the reason of a lot of failures. And then finally, I decided to connect the Latin code just to the encoder audio, because the model must be audio driven, not image driven. Well, this is how the encoder audio is made, and as you remember in the previous slide, the encoder audio is made by two inputs. The first input is much more like an image, because it's made by the current frame, what was before and what there is after, of course close, and this is treated like an image, and then I can apply a 2D convolution and not 1D convolution. That makes a difference. 1D convolution that is applied to the center frame with a wider window. So, but how we can animate this face with producing the best lip sync? So I provide a reference image, and then I have to modify this part in order to have the correct shape based on the input of the current audio input. I was inspired by a technique that is named in painting. In painting, you can find this solution in a lot of softwares, like, for example, Adobe, and is that feature that you use when you want to erase people from your picture or remove objects, where basically you create a mask, and the software using that algorithms is able to reconstruct the missing part based on the background. Of course, I don't want to do that, but I want to reconstruct that portion in the way that needs, because basically these kind of algorithms are developed to create the content in an unsupervised way, and so based on random results. Because if I want to cancel, for example, a people inside a picture, I don't care how is being reconstructed that image. But in this case, that we want to make the picture talk, I must be sure that for the current audio input, for example, the letter A, this portion is reconstructed with the shape of the letter A. So I had to modify something in order to make that working. And then something that struggled me a lot was the shape of the mask. That is very, very important. Until you don't begin to work with it, you can understand how important it could be. I realized that the shape and the size of the mask is vital for the final result. Again, is another important aspect. I studied a lot on creating the best possible shape. This is one simple shape, but now I have something a little bit more sophisticated, but more or less is that. So I use landmark extraction, to understand where is this portion of my face, and then I draw accordingly this mask. Why is it important? It's important because the deep learning is so powerful, really too much. What I mean? I mean that if the mask is too small, I realized that the deep learning model started to learn how to reconstruct this portion based even on micro expressions of my eyes, or this portion, for example. That's because the audio dimension is nothing compared to the size of the image, because an audio is made by 128 elements. This image is made by millions of pixels, so it's really unbalanced. And then I spent a lot of time trying to figure out what to mask and how much to mask. More or less, that is what produces the best result. But that's not all, because I had to study a training workflow where I use different masks with different shapes, with different behaviors. And also I applied transformations for each training, like scale, rotation, and even a change of luminosity. And translation is maybe one of the most important transformation that we can do. That because for several reasons, as we have to reconstruct always this portion, and this area is static from position point of view, and then the machine learning, the deep learning model reconstructed in a very bad way this area, and goes always overfitted. I solved this big problem introducing affine transformation, but not always, because affine transformations decreases a little bit the final image quality. And so what I do is to create several steps driven by the accuracy of the model. And then I switch to the next stage once the accuracy of the model is below a threshold. And for example, maybe in the first stage I have a bigger mask because the machine learning model must focus on how to reconstruct this face, focusing much more on the audio informations. When the machine learning model understood how to do that after a lot of iterations, then I can start to reduce the affine transformation, to reduce the mask, and to focus much more on image quality. That's because the way is already tracked. And studying this workflow is not so easy. Now I found more or less my way that is suitable almost always, but I have to say that sometimes changing actor, changing situations, I have to change some parameters of that workflow. But anyway, this is the idea. Well, here, finally, let's say that we finished our training, and then we can do our inference. How it works? Again, we start from a text. The text is converted in a WAV using Microsoft speech-to-text using neural voices. I do my training with my own voice, with the technique that I explained before, and I use a reference movie, let's say 10 seconds, 50 seconds, that swapping and inverting the final, the second part of the movie, I create a loop. All frames of that reference file are used as input. And then the output of our machine learning model is driven by the length of the audio that I processed, and for each chunk of that audio we produce one frame. So at the end we don't have the final movie, but we have a list of frames that we have to put all together. To do that, I use FFmpeg. It is an open source tool that you can find and is really famous. I guess that it needs no presentation. And I use it also for Optical Flow. That's something important because that improves a lot the final quality. Why? Basically, we shoot with an high quality camera with an high frame rate. That because shooting with an high frame rate makes each frame very steady. So I don't have movements, blurred portion maybe when people moves themselves, but that produces not smooth animation at the end. This is something that is not invented by me, or a problem that it's related on me. Even if you watch Netflix, for example, and you click the pause key, you see that a lot of time the frames looks like it was blurred. That's because they use this technique that is named the optical flow. How it works? To make all the animation smoother, there is that algorithm that, as I told you, smooth, blur, following the movement of the object from one frame to another frame, in order to make it much more suitable, enjoyable for your eyes. And that a lot because helps a lot, sorry, because if you don't do that, your final result is a bit shaky. that's it's difficult to believe, but that's how life it works. And again, it's not something related to me. All cinema industry stuck with this kind of problem, but it can be solved. And I use FFmpeg to create the optical flow. Is not just talking about blurring frames, again, because you have to process the frame and understand how it moves from one frame to another. Well, but we have still not finished, because to improve our final animation, we have to introduce the interpolation. Why that? Basically, in the training, as you remember, we created a special text. Special text containing all phoneme, the sounds of the language. But basically, you speech some sentences. So let's say, for example, that the letter A is at the beginning of the recording, and the letter T is at the end of the recorder. But now you produce a text that wants the letter A and the letter T very close. That is not a big problem, because the deep learning model is so powerful that it is able to merge everything and make it almost smoothly. The problem is that, as I already mentioned before, when you speech some vowels, some sounds, even if the letter, for example, is A, but the shape of my mouth could be different if after there is one sound or another. And the same thing happens when I'm coming from one sound to another. So I can say this is the shape for A, but when talking in a natural language, that shape changes based on what there is before and what there is after. And that makes things not much smoother. And this is not something that can fix the optical flow we talked before. And then I use the morphing, but in a special way. So the idea behind is that I skip a number of frames and then make the interpolation between the starting frame and the ending frame. In this example, in this slide, I skip just one frame, but basically for a good result, you have to skip 2 frames. And in this way, all the animation is smooth. But we can do this morphing using computer graphics, like, for example, the OpenCV, because of the ghost effect. If you, I think that everybody knows what it is the morphing, how it works more or less. So basically, you have an input image and a final image, and using also landmarks, you move the pixel and you produce a fade in and a fade out to create that transition. But the ghost effect is most always visible. To avoid that, we leverage a property of the deep learning and in this case of the encoder-decoder architecture. I told you before to keep in mind that architecture that I explained before, because there is a reason why. The reason why is that we perform this interpolation, this morphing, not on pixels, but on the latent code. So on the red here, on the red portion, and this portion is made by 512 elements and not millions of pixels. and I do the interpolation. So what I do is to take the picture, the source, to process with the encoder, just the encoder, and the same thing with the destination frame. So I give it an input to the encoder and produce the latent code representation of both frames. Then I do a basic interpolation of these two arrays, and each step is used as input of the decoder that is able to reconstruct. In this way, the animation is really natural. You have no ghost effect or strange artifact coming from computer vision algorithms, and that is amazing. Well, anyway, this technique again is amazing, but could have some problems. Problems because you don't know how is the produced WAV file from the speech to text, how people talk, maybe a word is spoken much faster than another. So I can say that skipping 2 frames is a good value for almost all situations. But if you want a much more accurate result, you have to know where important sounds are located in your WAV file. To do that, I use a new API coming from Microsoft, exactly from Azure Cognitive Services, so inside the speech SDK. And this API is the DCM, is named the DCM extraction. Basically, what it does, it is born for completely another task. Is born to animate puppets with for cartoons, for example. So what it does is taking an input, an audio, and producing a JSON file telling you where phoneme of that language is located and providing the time offset. That works great in US English, because so far at time of speaking this API works with just with that language, and I hope really that they will release this API for all languages. Anyway, what I did is to leverage this API and to find how the best marker, the best place of the frames to be skipped inside my frames list. It means in a dynamic way. So maybe that for that speech, in this case, first I have to skip 2 frames, but after no frame to skip, and again just one frame. So in this way, everything is much more accurate, and of course, the results are far away much better. Well, we are going. Okay, finally, we are. We have our video, our AVI MP4, and we have to use it, because so far what we did is just to produce a video that's starting from a test. We produced a video that could be also amazing for people that loves deep learning, but everything is useless if it's not used in a project in a smart way. Well, Here the architecture. Basically, what we does is to use Azure Bot Framework to create our chats, and we also use the text chat that comes from the one provided by Microsoft. Of course, has been customized to interact with this service. Anyway, the idea is that when an intent is triggered, we have to provide a text reply. Well, that text reply is used as input of my deep learning model that I talked so far, and we produce a static video related to that intent. It means that if you change your text, you have to create again a new video. But so far, with a good hardware, we can create a video at most in 1 or 2 minutes. So it's not a big problem. And here is the architecture. So we upload our files into an Azure storage, and then we use Azure Media Service to encode that videos. We have some jobs inside the Azure Media Service, and finally we use another component that is the streaming endpoint, and sometimes, not always, we use another component that is named multi-protocol dynamic packaging basically for DRM. And when an intent is triggered, of course, the NLP engine that could be Microsoft Lewis, but in this case is our own NLP engine, of course, must send the text sentence to the web chat, but also ask to the streaming endpoint to download the video related to that intent in order to be displayed at the side of the chat. How it works? Of course, we need an idle video. So we produce, for example, 10 seconds of idle video where our avatar says nothing, and it is being created in a way that can work as a loop. To do a loop, I explained it before, what you need is to swap, to copy and invert the video, and putting together you create a loop. When there is a request, basically we swap very, very fast the idle with the video that has been downloaded from a streaming endpoint, and then when it's finished, we swap again with, of course, a transition with the idle video. And I have to say that the streaming endpoint is very, very, very fast. So far, we had no problems, and we can download and switch almost in real time. From this point of view, is amazing. Well, this is much more in detail what I already explained, but I want to go forward, and that's the final result. So basically, this is the structure of the product that we want to release, I hope in a few weeks. So we have the web chat that has been customized again, not only from a front-end point of view, but we did some modifies in order to interact also with the avatar. And then side to the web chat, we play our videos, swapping accordingly to the text that has been triggered in the web chat. Of course, everything can work using microphones, and so you can interact also using just voice. Thanks to the bot framework, all that has been already implemented. So we don't have to reinvent the wheel, and we use all features. All that features comes straight from the bot framework, and was really helpful. If you want to try this service, are curious about that, it's still in preview, but if you keep in touch with me, write, and I will be happy to provide the access to the preview. Well, finally, about the hardware, basically we used, of course, Microsoft Azure. The GPU that we used is the V100, and for training you have to consider for a woman 2 days. For a male you need up to a week. But why? Because of the skin. So basically, for example, in my case that I have the bear, it needs much more detail in this area, and so the deep learning model must spend much more time trying to figure out how to reconstruct all my details. And then a woman in this case is faster to train than a male. But that's it. Okay, about optimization, of course, we can do a lot of things, but we are going to finish our presentation, and we can talk about that a lot. Anyway, basically, we are going to improve that solution, and the algorithm changes always. So what I told you now, today, is totally different the approach that we used 6 months ago. And so we continue to improve everything and creating and modifying sometimes a lot. And I hope to be able to talk about the evolutions of this project in the future. So, thanks again for joining. I hope that I was able to balance the technical part with the storytelling. It was not that easy. Anyway, here I am for any questions, but you can write to me if you need support, much more detail, some aspect, some parameters, everything you need. If I can, I will be happy to help you and to share information.
Thank you very much, Sebastiano. So far, there are no questions, but if anyone has something to ask, please, this is the moment. I think it's quite the journey from the very beginning to the current stage of the avatar. So
Sometimes
yeah, yes, yes. No, it's impressive. In the end, as you said at the beginning, all these, let's say, drawbacks, small failures, let's call it failures, help you to reach, let's say, some other stage, some other like approach, because usually sometimes we might be, let's say, stuck, like something is not working, or the accuracy, the performance is not as we expect. But then we get some, even receiving some different error message helps, because that means that you can think of something different, or apply some other approach.
A lot of times it's hard to figure out where the problem could be, because maybe you know in your mind that the model must be correct, but you realize after 3 weeks that everything was in fact correct, but maybe you did a mistake in the shape of the mask. And there is no documentation, there is nothing that tells you that the problem is there. And something that is easy to fix, it's hard to learn because really there is almost nothing about that. There are some papers, yes, that you can read, but they are focused to do something else, not to do all that process. Anyway, here we are. I'm of course proud of my project, and I miss to talk with someone, to people that were working on a project like that. So I would be happy if I could talk with other developers or data scientists that are interested in projects like that, because exchanging information and knowing each other is always a good way to learn, and I love it. So, who knows?
Excellent. Excellent. Yes, yes. So the invitation is there, and hopefully, yes. No. Thank you. Thank you for joining. Thank you for your presentation. It was really, really impressive, and we feel honored to know about this project. So, looking forward to meeting you in some conference.
Yeah. Thank you again. Bye.
Have a great weekend. See you.
Bye.
All right. So, well, this was quite an impressive presentation. As you can see, well, sometimes you need some idea, and then you start developing it. You think how to improve it, how to implement it. So, well, do you feel tired? Are you tired? Well, right now we are going to make a 3-hour break. There are no more sessions. Although I am now running because, well, there is another global AI bootcamp in Bulgaria. So right now I have to present. So I will just close here really quick. Yeah, the Global AI Bootcamp is organized in different countries, in different cities around the world. Some events are virtual. There are hybrid events, and all others probably on-site. I think in Madrid there is one on-site, but I don't remember if it was today or next week. But yeah, you see. Okay, so very quickly I will share the link for the next block of sessions. In exactly 3 hours, we will start with the next batch of sessions. So see you in 3 hours. Okay. So that will be all for this part. Thank you again, and see you later. So go back to sleep, go for some lunch, whatever. Okay, so see you in 3 hours. Thank you. Bye.